from originally Philadelphia, Pennsylvania. My program is, I'm in Physics and Astronomy here, graduate student, and I am currently in my 4th year, which is unbelievable. So I work with Dr. John Thorstensen here in the Physics and Astronomy department, and I do astronomy. Very, very much astronomy, very not much physics. There's certainly physics built in. But we study stars, specifically a kind of star called a cataclysmic variable, which is just kind of a fancy way of saying it's a binary star system. So 2 stars, one orbits around the other one. So like the Earth orbits around the sun, a smaller star orbits around a really dense fragment of an old star. And that dense fragment of the old star at the center eats the smaller star over time. So we study those kinds of stars. There's a lot of things that you can do with these cataclysmic variables, CVs we call them, I'll just say that. But a kind of new one that is, to me personally, very interesting, and I think to virtually everyone very interesting, is the idea of trying to find exoplanets, or planets that are not in our solar system, but that exist orbiting around other stars. And there was this big satellite mission that launched in 2009 called Kepler, which has so far found like thousands of planets. It's incredible. But it was looking around very specific types of stars and using a very specific method to find them, and it's been wildly successful. But that's really opened up the floodgates of, well, we know there are planets like everywhere now. It's extremely common for stars in the galaxy, rather, not the solar system, to have planets. We know it's the norm rather than like not the norm. And so people are trying to find new ways to discover them. And so one thing you can find from these CVs is you can, if they're oriented well enough towards us on Earth, we can actually see the one star passing in front of the other one. And we see that by a dimming of the light that they're emitting at that time. And if you watch them for long enough, you can see how quickly that happens. You can find, and so you know basically exactly when it's going to happen. It's the same reason that the Earth, every 365 days, it's going to make an orbit around the sun. And so these things are really fast. It's like every hour, one of these stars is going to make an orbit around the other one. And that doesn't really change. It's the same way that the Earth's orbit around the sun doesn't really change, except when it does. So very, very rarely you see these changes in orbits that need to be explained by some physical mechanism. And the idea being that, like, for years people had said, oh, well, maybe it's planets, but we don't know of any exoplanets that really exist, so that's not something worth pursuing. Now that we know these exist, I'm very interested in pursuing that. Dream job, I would definitely be working for NASA right now. So.